Another example, draw a picture, only given one angle. Again, this is another obtuse angle. So this is my angle A, 94 degrees. Side A is 15. I want my other side here. So this is going to be angle C, side C is going to be 12, which leaves me with angle B. So again, angle, side, side. This one is now possible. If you look, I have the largest angle, and this is longer than this side. So this one is possible. I can do this, okay? So in this case, when I have an obtuse angle and the side opposite is greater than the side adjacent, I go through and do law of sines. I don't have the luxury of getting one of my angles right away like I did in the previous examples. The only thing I can find is angle C. I don't have angle B or side B, so that's going to be the last stuff that I'm going to look for, okay? So I'm going to start with the pair that I have. Again, you're always going to have an angle and side pair that you can keep together. So I have the sine of 94 over 15 is equal to the sine of angle C over 12. So this is different from the previous examples too, because now I'm going to have to get this by angle by itself. So if I cross multiply, and I'll go through and show all the work this time again. So 12 times the sine of 94 equals 15 times the sine of C. I divide by 15. And I probably just could have multiplied by 12 to begin with, but all right. Sine is by itself. To get the angle by itself, I have to do inverse sine of both sides. So the inverse sine of this mess, and again, same as before, it has not changed. I need to make sure that I don't do any decimal approximations till I'm done, okay? So I have that big ugly mess. I'm going to put that big ugly mess in my calculator all at once. And I need to be able to see that big ugly mess. So inverse sine again is above the sine button. Inverse sine of 12 times the sine of 94. Make sure I close that one, divided by 15. So to the nearest 10th, I have 52.9 degrees for angle C. Now I can subtract to get angle B. So the measure of angle B is going to be 180 minus 94 minus 52.9. And I get 33.1 degrees. So now these are both decimal approximations, and this is where it gets to be tricky, okay? So the last thing I need to solve for is I need to solve for this angle B. And you can go back and use this whole number and do this. As long as this is the only thing and it's the last thing that you're doing, you should be okay. You should be pretty close to the exact, because we rounded to the nearest 10th here, we should be fine. So I'm still going to use this same pair. I'm still going to use the sine of 94 over 15. And then I'll do the sine of 33.1 over B. And now I'm back to just like it was in the other examples. So B will be equal to 15 times the sine of 33.1 over the sine of 94. But as you're doing your homework, if you end up getting off by a little bit, it's because you're rounding too soon in the problem, and then you're using rounded values throughout the problem, okay? And it's just something that you have to be aware of, and you have to be careful. So 15 times the sine of 33.1, close my parenthesis, divided by the sine of 94. And so this is approximately 8.2. So, all done. I'm going to go back and check. Okay, so this was approximately 8.2. Angle C was about 52.9, and angle B was 33.1. Largest angle, longest side. Smallest angle, smallest side, in between. Looks good to me.